This chapter looks at database triggers. Whenever an application program attempts to make changes to a database file, DB2400 can automatically call a trigger program. The application program could be performing either an insert, update, or delete operation on the database file. A trigger program on the AS400 is written and compiled just like any other program. The add physical file trigger command is used to associate the trigger program with the physical file. DB2400 supports 6 database conditions for which we can code triggers. They are before insert, before update, before delete, after insert, after update, and after delete. Whenever a particular condition is true, DB2400 will call the corresponding trigger program. Suppose we have written a trigger program custtrg that will perform certain validity checking before allowing a record to be inserted into the custpf file. We use the add physical file trigger command to associate the program with the physical file. We specify custpf on the file parameter. The trigger time parameter can be set to either before or after. Here we specify *before since we want the program to run before the record is inserted. The trigger event could be insert, update or delete. Here we specify *insert. On the program parameter, we specify custtrg. Finally, we specify *yes for the replace trigger parameter so that this trigger program will replace any other program that might already exist. 2 points that should be kept in mind. A trigger program must exist before it can be associated with a physical file. Once the program has been associated with the physical file, we can delete and recreate the program without having to run the add physical file trigger command again. To remove a trigger program, we use the remove trigger program command. Here, we specify the trigger time and trigger event parameters. In case we want to remove all the triggers from a file, we can use *all for the trigger time and trigger event parameters. Triggers cannot be added to or removed from a file that is open. Let us look at trigger programs. It can be coded in RPG 400, COBOL 400 or any other high-level language that is supported on the AS400. Whenever DB2400 calls a trigger program, it fills a trigger buffer with the before and after images of the database records along with certain control information. A trigger program should have 2 parameters specified. One for the trigger buffer and the other for the buffer length. DB2400 places the length of the trigger buffer in the buffer length parameter. Let us now look at the trigger buffer. Some of the information in this buffer is of fixed length, while some are of variable length. Let us take a look at the fixed length portion first. This contains file name, library name, member name, trigger event, trigger time, commit lock level, a reserved field, the coded character set ID, and another reserved field. Since the number and size of fields in a record vary from one physical file to another, the length of the fields that hold the record images in the buffer will also vary. The variable portion of the buffer contains before image of the record, after image of the record, null field maps for both the images. Each null field map is a series of one-character flags that indicate whether the corresponding field is null or not null. A 1 indicates that the corresponding field is null and a 0 indicates not null. The fixed portion of the trigger buffer also contains 8 fields that identify the location of the fields in the variable portion of the buffer. For each of the variable fields, it contains an offset, which is the number of bytes from the beginning of the trigger buffer to the first byte of that field. The 8 fields are the before record image offset, the before record image length, the before record null field map offset, the before record null field map length, the after record image offset, the after record image length, the after record null field map offset, and the after record null field map length. The trigger program can be coded to access the required fields from the buffer. In case the trigger program wants to prevent the insertion of a record, it can send an escape message back to the application program that attempted to insert the record. The application program should be designed to handle errors signaled by trigger programs. It is advisable to have the trigger programs open files under the same commitment control environment as the application program. In this case, the application program will perform all commit and rollback operations. If any changes are made to a physical file's record format, the trigger program should also be updated to reflect the changes. When referential integrity constraints are also placed on the physical files, DB2400 sequences the triggers and referential constraints depending on the type of event that has occurred. In the case of an insert event, DB2400 uses the following sequence. It first calls the before trigger. Next, it inserts the record and performs validity checks other than the referential integrity constraints. It then calls the after trigger. Then it checks the referential integrity constraints for the dependent file. And finally, it checks the primary and unique key constraints. In the case of an update event, DB2400 sequences the triggers and constraints in the following order. First, it calls the before trigger. Then, it updates the record and performs checks other than the referential integrity constraints. Thereafter, it checks the star restrict constraint for the parent file. The next step is to call the after trigger. Then, all the star no action integrity constraints are checked for the parent file. Thereafter, All referential integrity checks are performed on the dependent file. And finally, it checks the primary and unique key constraints. In the case of a delete event, DB2400 sequences the triggers and constraints in the following order. First, it calls the before trigger. It then deletes the record and performs checks other than the referential integrity constraints. Then, it checks the star restrict constraint for the parent file. The next step is to call the after trigger. Thereafter, all the star cascade integrity constraints are performed for the parent file. Then all star set null and star set default referential integrity constraints are performed for the dependent file. And finally, it checks all the star no action constraints for the parent file. Lastly, we will look at some factors that should be kept in mind when creating triggers. A trigger program may perform a database operation that will in turn activate another trigger program. Take care to ensure that a call to a trigger program does not result in infinite recursive calls to the same trigger program. A trigger program cannot modify the record that activated the trigger. No conflicting operations are allowed in a trigger program, such as a trigger program called on an insert event trying to delete the same record. With this, we conclude the topic on database triggers. Summary. Trigger programs can be coded for 3 different database events: insertion, deletion, and updation. We can specify whether the trigger program is to be activated before or after an event occurs. The add physical file trigger command is used to associate a trigger program with the physical file. The trigger program can be coded in any high-level language supported on the AS400. We saw the sequence in which DB2400 processes the trigger programs and the referential integrity constraints.